All right then. Good afternoon, everyone. This is Zach from NCache. I hope everyone can hear me all right. It's been a while since we've all come out for this series on NCache. And with me today, I have our senior solutions architect, Ron Hussein. Ron, can you hear us all right?
Yes, I can. Hi, everybody. This is Ron. I'm going to be,
Wonderful.
the technical presenter, and Zach is with me.
Great. So we have quite a nice turnout. Thank you to everyone for joining. I hope everyone's been doing great. Today's webinar is going to be based on NCache architecture. Now, we're going to be covering an overview of distributed caching and how it resolves your bottlenecks in .NET and .NET Core. We're going to go over common use cases, as well as the distributed cache architecture and clustering details, as well as any of the questions you might have in regards to not only NCache, but caching in general. Now, anytime throughout this webinar, we do have the option for questions here in the GoToWebinar Questions tab. So please take a look at your convenience for the Questions tab, and once you write in a query, I will be able to bring it up during the presentation to be answered by Ron or myself. We also have a small amount of time at the end of this session in order to be able to go through any other questions that come in, but we're looking forward to having a great time. So without further ado, I'm going to hand it over to Ron, and let's get underway.
Very good. Thank you, Zach. Everybody, as Zach just mentioned, that today's topic is NCache architecture. So in this webinar, I'm going to cover in great details how NCache clustering works, what are the most common topologies that you can choose from, what is the main benefit of NCache in terms of your application use cases, what are those use cases, and how you can take full advantage of NCache within your server applications. So I hope everybody can see my screen. So if I can get a quick confirmation on that, I will quickly get started on this. Yeah, I think we're all good. If you can, there you go. I think.
Yep, looks good.
Perfect. Okay, so let's quickly get started with this. All right, so let's first of all define what NCache is. And for that, I will have to go ahead and define what a scalability problem is, and then how NCache is able to resolve that scalability problem. So in a typical server architecture where you have applications deployed, it's usually more than one instance or more than one server where those applications are deployed. So it's safe to say that your application tier is something that's very scalable. You can add as many servers in an application tier. You can construct a web form, an app form, where multiple application servers or web servers are hosting the same application, but they are working in a team, and they're dividing the request load among themselves. And if you go towards a newer architecture with even microservices architecture, you have ability to individually scale your application services, microservices, which need more computation or more request handling capacity. So app tier is very scalable. It's linearly scalable. As you grow, you're able to handle more and more request load. The issue comes into play when you're dealing with a database such as a relational database, because all of these applications, regardless on a level of scalability, how scalable they are, they would always have to talk to a backend database. And when they talk to a backend database, that's usually a single source, and that's not very scalable. It's very good for storage. You can have a lot of disk resources, so you can draw storage benefits from it. But when you have a huge transactional load on your applications, and that translates onto a database transactional load, databases tend to choke down. And that's the main problem, where the application struggles with request handling. It's not scalable, and user experience is compromised as well. NoSQL databases somewhat resolve this problem. They can have a NoSQL, you can have a NoSQL database, but that requires that your application is re-architectured in such a way that it stops using a relational database and starts using a NoSQL database, and that's a big project. So NoSQL is not always a solution to a scalability problem. So what should we do this? What should we do now when we have this? Solution is very simple. You should have an in-memory distributed cache like NCache. First of all, it's in memory, so the number one benefit that you get is that your application's performance will be increased. It's super fast in comparison to a relational database. And the main benefit is that it's linearly scalable. Unlike a database server, which is usually a single source, NCache can reside on multiple servers. It allows you to create a cache cluster, which can run on multiple boxes. And as your requirements or needs grow, where you have to have more request handling capacity, need to be handled from your application tier, you can add more servers at runtime in the cache cluster. And nice thing about NCache is that you use it in addition to a relational database or a backend database. It's not a replacement of your conventional data sources. It's something which will complement the existing data sources in such a way that it's able to increase performance for your applications. It's able to increase the request handling capacity for your applications. And as you grow, on the application end, you can always grow the number of servers in the cache cluster, because these are servers in a cluster, so they work as a team, and they're able to divide the request load among themselves in such a way that they give you linear scalability as a result. So NCache is a linearly scalable model, and it's very easy to use. Let's talk how the deployment architecture works. So in a typically large production environment, this is how NCache would look like. You would have a bunch of servers. These could be Windows or Linux servers, designed in such a way that NCache sits in between your application and the database. For example, you can start off with 2 or 3 NCache servers, and then you can grow up to 4 or 5 NCache servers. And different kinds of applications, for example, your ASP.NET or ASP.NET Core web apps, your .NET or .NET Core web services, or .NET or .NET Core server apps, or even it could be Java, Node.js. So those applications can also take advantage of the distributed caching. NCache itself is written in .NET Core. It runs on Windows as well as on Linux boxes. Similarly, your applications could be on any platform and it would work without issues. Typically, we recommend that you have NCache on dedicated set of servers, which are hosting just NCache, so that you have dedicated nature of resources for NCache, and then your application servers are on a separate tier, so that you have dedicated nature of resources for your applications as well. But there's another deployment option as well, where for smaller configurations, you can have NCache sitting on the same boxes where your applications are also running. So that's always a possibility with NCache. But as discussed, the recommended option is that you have a separate cache tier, as shown in the diagram, and then NCache sits it between your application and the database. Idea here is that you cache whatever data that you most frequently use inside your applications. It could be a reference data or a transactional data. By reference, I mean data which is more read intensive, and by transactional, I mean data which is read as well as write intensive. And once you know what data to cache, you can call that data to be your working set, and for the first time you can retrieve that data from the database, and then you can also add it inside NCache, and subsequent calls can be handled through NCache only, and you save expensive trips to the database. This is what we typically term as cache aside pattern, where any changes that you make are also propagated to cache and then to database. And any data which doesn't exist in the cache, you always fetch it from the database and keep it inside NCache, but you always check cache first, right? So if you find data from within the cache, you don't have to go to the database, and you return from that point. The alternative approach of this is to use read through or write through, which is represented here by dotted lines. NCache has a feature which can automate this, where it gives you cache through option, and it is termed as read through for reads and write through for writes. That'll work in such a way that you always use cache as your main source, and you implement a read through or write through handler on the cache, and that will take charge of or that will take a job of updating the backend data sources. So whatever read operations you perform, if data doesn't exist, it will seamlessly go to your database based on your provider, and it will retrieve it for your application and also return to the app and also store it inside NCache. And for updates, it will update the cache as well as the database in a sync or async approach, depending upon what model you have called from the application. So I'll share more details about read through, write through, and caching patterns, but just to give you a high level deployment picture, this is how you would see NCache deployed in a server form, where multiple applications forms, they can connect to NCache, and then they can take advantage of a distributed caching where in-memory access improves application's performance, and having multiple servers in the cache tier is able to give you linear scalability. I hope that was clear. Please let me know if there are any questions.
Well, luckily at this time, looks like there are none. So please feel free to continue.
Very good. So next I'll talk about NCache scalability numbers. We just mentioned that NCache is able to resolve the scalability problem for your application. So NCache itself is linearly scalable. So with application tier being scalable, having a database bottleneck resolved through a linearly scalable model, here are some numbers that you can take for a reference. These were our benchmark tests that we conducted in our QA environment. We used servers which were high on CPU and RAM so that we could really stretch and then use them with high, use them in a high load situation. So we started off with one server and we kept on increasing application load with 2 servers, and as soon as a set of servers got maxed out on CPU and RAM capacity, that was the point where we added another server. So that's the thumb rule, where you can keep using existing cache servers, start off with 2 NCache servers, and when you see that those 2 servers are being maxed out on hardware capacity, if your CPU is being maxed out or your RAM is being maxed out, that's the point where you make a choice that I now need to scale out and I need to add a 3rd server in the cache cluster. And this is exactly what we've done. With an average of 1 kilobyte object size, we kept on increasing application load and kept on increasing number of servers until the given set of servers were maxed out. And this was not a touch and go data, it was a real life application data, but simulated in our QA lab. So with 2 servers, with 3, 4, 5, up to 5 servers, we were able to handle 2 million requests per second with average of 1 kilobyte object size. So it was a combination of reads and writes consistently applied on the cache. So overall 2 million requests per second throughput was achieved, and at the same time without compromising on the performance. So throughput is not just having a lot of requests per second, but individual requests latency should also be maintained, and it should be super fast. A video demonstration of this as well as a white paper is published on our website as well, and that's something that you can review as well. Okay, let's talk about some of the common use cases of NCache. The number one use case is caching application data. We call it app data caching. Now, this is the data which is coming from a backend database. Now, we've already established that database is slow in general because it's disk-based. In comparison, RAM is a faster source. And the other issue is database tends to choke down under high traffic. If you have a lot of transactional load, there's a single server, it is expected that it is not going to give you the needed performance that you need on the application end. So it makes a lot of sense to cache application data inside your applications by using NCache. And it's very simple that you introduce NCache APIs. You simply call cache. You connect to cache by calling cache initialization APIs. Once you're connected to the cache, then you can call cache.add, update, remove, or even cache.get to retrieve data from the cache. So I'll show you some examples towards the end, but idea here is that whatever data that you think that you're going to read more than once, be it reference data or transactional data. For reference data, NCache is going to add a lot of value because it doesn't have to go back to the database to retrieve any changes, right? So data in the cache is going to be usable for a longer period of time. And while you're using data from NCache, you don't have to go to the backend database, and that improves your application's performance, and it gives you scalability because NCache is scalable in comparison. So it's very intuitive that you cache all of your reference data, but we also recommend that you should cache some of or even most of your transactional data as well, because in our experience, any data that you read more than once, even if it is something that you read 2 or 3 times, we recommend caching it, because even if it is being changed in the database, and after that change, if you read more than once, 2 or 3 times, it makes a lot of sense to cache that data so that you don't have to go to the backend database. And we have features built into NCache which can give you 100% synchronization with database as well. So that's something that you can also always consider.
Ron, I had a quick question that came in,
Sure.
primarily being, do I always have to go to my clustered cache over the network? I'm scared that network issues might lead to my applications not working. Is there some way to maintain some of my data locally?
Okay, so typically the default deployment is that we recommend that you have NCache on separate boxes and then your application on separate boxes, right? So that and NCache is based on a TCP/IP protocol, so it is a network call. There is a feature called client cache, which is a local cache which sits on the application boxes, and in some cases, if you really need more performance and you don't really want to have any kind of latency caused by network, it can also be made in proc, which means that it will sit inside your application process. So when that happens, the subset of the data is automatically brought inside client cache. So that will save any process to process communication, and then also will save any network communication or any network overheads. So we do have a feature. That's something that I'll cover once we will go to our topologies. So I'll share some more details. But just to give you a quick overview, this is how client cache works. It's a cache which sits on the same box where your applications are. And idea here is that it will not require frequent network trips if you have client cache enabled. And this works without any code changes. So I hope that answers the question. Please let me know if there are more questions.
Yep. Sounds good, Ron. Take it away.
Very good. The next use case of NCache is, in a web application, if there are, some requirements of caching user data, right? And typically it's ASP.NET or ASP.NET Core session state. Now, this data doesn't belong in the database because it's a transient data. It's a data that a user will construct, and it stays in the application scope while that user is active. In some cases, you may keep it in the database for a historical point of view, but in most of the cases, the data belongs to a user. So Microsoft ASP.NET or ASP.NET Core Session, there are few options. You can use state server, you can use in-proc, you can use a database server. All of these have options have issues. For example, in-proc is a single point of failure. You have to use sticky session load balancing. ASP.NET State Server is again a single point of failure, and it's not scalable. Database as an option is again not a single point of failure because you can back it up, but in some cases it could be a single point of failure, but it's slow and not scalable. So what should we do here? Again, consider using NCache for ASP.NET and ASP.NET Core session state caching. It works in such a way that you plug in our provider. It's a no code change option, but as soon as you plug in NCache inside your applications, NCache becomes your main session storage. And idea here is that it's going to be super fast because it's RAM based. It's very scalable because there are multiple servers. And within NCache, once we will progress into the presentation and I'll cover topologies, you would understand that NCache has backups with the help of replications. And session data is a user data, right? So it's a data that you wouldn't want to lose in any situation, because once you lose that data, that's an impact on the user, that's an impact on the business. So with replication, data is backed up as well. So if I have to list down the benefits that you get, and first of all, you're going to improve your application's performance because of in-memory access. You have multiple servers supporting your applications for session caching, so it's very scalable. On top of it, it has high availability and data reliability features built into it. So there is no session data loss or downtime to the application in case any NCache server goes down. And you don't have to use sticky session load balancing anymore because NCache is a shared entity. Request can go to any of the web server. It will always be able to find data from NCache based on our protocol. So all of this without any code changes as well. Another use case here, you can also bundle your view state if you're using ASP.NET web forms. That's where it's also going to cache view state. View state becomes heavy. It eats up a lot of bandwidth. It becomes part of your request and response packets, and it's always sent back to the browser. And it's never really used there, but it is something that is stored on the browser, on the client end. And when you post back, that's where the view state is brought back on the server side. So with NCache, we allow you to cache view state on the server side. So your payload doesn't have a heavy view state attached to it anymore. That improves performance. Although view state is something that's always stored on the browser end, but if you keep it on the server side where it is needed, it's going to improve overall application behavior. It will not eat up your bandwidth anymore because the actual request and response packet doesn't have a heavy view state attached to it anymore. And it's also going to be very secure because view state is stored on the server side, and then you can set up some encryption and some security features on top of it. And this is also a no code change option, but it only applies to legacy web forms. So I would recommend that you can, if you have an ASP.NET web forms application, you should consider caching view state as well. And then we have ASP.NET and ASP.NET Core response caching. So static pages or page portions within a page which are static, you should consider caching those page outputs. And in ASP.NET Core, we have a response caching option that you can choose. And this is also a no code change option. In addition to this, we also have ASP.NET and ASP.NET Core SignalR backplane, because in a web form, if you're using SignalR, you need a backplane as a must. And typical backplanes such as a file system or a database that can have all those scalability and performance challenges that we just discussed. With NCache, it's going to be super fast and very scalable and reliable because we're using a very reliable messaging system behind the scenes. So these are some of the use cases that you can leverage on ASP.NET or ASP.NET Core applications. Before I move on, Zach, I think there's a question posted.
Yeah. So the question came in from basically saying, and DB by default. So in the midst of I wanted to wait until you finished it, but the question basically is asking on that. And in case, would you be able to elaborate on the question, sir? Because Ron, is NCache also suitable for data publishing purposes with the requirement where the requirement is to save data in memory cache with options to sync data in the database as the background process? And can NCache take care of that sync mechanism between memory cache and databases by default?
Yes, that's a very good question. For advanced cases, this is something that could always be a requirement. It works in two ways. One is that your application is now using data which is coming from NCache, but data exists in the database. So these are two different sources that need to be in sync for reading as well as for writing purpose. Now, if the application that is connected to NCache and database is the only application which is responsible for changing data inside NCache and database, we recommend that you use read through and write through. And yes, this can be done in async or sync manner depending upon your requirements. So what will really happen is whenever you try to fetch some data from NCache and it doesn't exist in the cache and you want it to be cached, you would automatically call read through, and that will read from the backend database based on your code. And similarly, if data is coming from a database, and again that data needs to be updated in the database as soon as you update data in the cache, In that case, you will make use of write through. Now, write through can also be write behind, which means one moment, which means data has to be updated inside NCache and in the database by using your write through handler. And if you want async invocation of that, in that case, you can use write behind. So it can be done in the background. But again, NCache and your application is responsible for that, where NCache is calling your code and your application is invoking that. Another situation could be that there are other applications which may be changing data in the database directly and your application is not aware of it. So in that case, what will really happen is you need to use our database synchronization features. You should come up with custom dependency. You know, SQL Server has chain notification. We have database dependencies. So there are a lot of synchronization features where any change in the database is captured by NCache automatically, and you can again use read through and you can reload data inside NCache as well. So to sum it up, NCache can handle both situations, where either it's your application which is the only entity changing anything inside NCache and database, or in a situation where database can be changed outside the scope of the application which is using the caching. So both scenarios are covered, and NCache will give you a 100% sync option for these cases. If you're talking about memory cache, typically memory cache is also featured by ASP.NET, right? But if you're referring NCache as a memory cache, so I've already answered the question. So please let me know if there are more questions, and we can take it from there.
Sounds good. I think we can move on.
Sure. All right, so next I'm going to cover pub/sub messaging. As you can see, NCache is already shared between applications, right? So it's an entity which you can use for your data requirements. You can add data to it, you can retrieve data from it, you're able to get performance and scalability benefits from NCache. You can extend this use case by using NCache as a messaging platform as well. So NCache messaging is very powerful within NCache. It's an async event-driven mechanism where multiple applications can drive messaging requirements or app coordination requirements among themselves. If you need multiple applications to talk to one another, building communication is a challenge. So you would have to rely on something which is a centralized entity. NCache is that entity, and with its messaging support, it is able to give you that option where one application can add data or messages to NCache, and those messages can be propagated to all the subscribers on the other end, the other applications which need those messages. Similarly, this could be data-driven messages as well. For example, any data gets added, updated, or deleted, you get notified about it. These could be some custom application messages or data-driven messages. So it covers both areas, where any data being populated inside NCache and you want other applications to be aware of it, you can drive messaging requirements through that. Or it could be custom messaging or application-driven messaging, where one application needs to talk to another application. It's again based on in-memory scalable model. It has reliable replication options available as well. It's based on conventional pub/sub messaging platform, where we have a concept of topic, and we have a concept of message broker where multiple applications are connected to it. So you can have publisher and subscriber applications defined. Publisher applications publish messages to NCache, which are then transmitted to all these subscribers, and then subscribers can also send their own messages to NCache. NCache acts as a communication platform between these different applications. And finally, we have another use case, which is full text search. So if you have an application and you need to drive any full text search requirements from NCache, you can consider using our Lucene.NET based full text search features. Typically Lucene API is a standalone, right? With NCache, you can extend it on multiple servers. NCache gives you an ability to load indexes inside memory as well. So NCache would use disk-based indexes, but it allows you to actually extend the storage and request handling capacity by having multiple servers to it. So although it's disk-based, but it's still going to be better than a single source on the database, because in cases where you have a lot of transactional load, each server will be responsible for its own set of indexes requests. So it's going to be very scalable. It's going to be very reliable as well, because this is a persistent store when it comes to Lucene indexes. Persistence itself is a feature within NCache. Any data that you store inside NCache can be persisted on the disk as well, or based on some database providers. It can be persisted on some databases as well. But Lucene is the only feature where NCache uses disk in comparison to RAM, because the nature of use case is such that it requires data to be persistent. I hope it was straightforward. So these were some of the use cases. Again, within these use cases, we have a lot of features. Any kinds of applications, any specific requirement within an application can be fully handled using our object caching and session caching features.
Just a quick question, Ron. Is there a way for me to access my data in the cache like I do in my MySQL database? I want to be able to run SQL queries on my cache data. Can I do that?
Sure. So NCache, first of all, supports SQL search and link queries. So if you have an ability to write an application which can simply connect to NCache and then run criteria-based searches, so that's the easy option that you can utilize, where you write a criteria-based search. For example, you can select all products where product.price is greater than 10 and less than 100. Or you can find all products based on a category. You can find customers based on a region. So you can come up with SQL-based searches or link-based searches, and NCache would give you the data from the cache. So that's one option. The other option is that we have a link pad integration. So if you just want to visualize data without having to go through an application development, so link pad is an easy way out where you can run link queries and then you can visualize data by running link queries. And then in our upcoming release, the third option is that we're giving a data analyzer tool. So we will give you an automated way, a monitoring tool, which will give you ability to monitor your data which exists in the cache. And it will give you those criteria-based search options from a GUI. So that's something which is in the pipeline. Requirements have been completed. Dev work has been completed. I think it's going to be part of our next release.
Definitely looking forward to all of that.
Perfect.
Yeah.
Very good.
I think we're good for now, Ron. Let's. I'll save a couple of these questions for the end as well, because we got some interesting ones. But yeah, let's keep going.
Sure. So next, I'm going to cover the clustering, the dynamic hash cluster. All the details about it. NCache is based on TCP/IP based cache clustering protocol. It's our own implemented cache clustering. We're not using any third-party or Windows clustering for this matter. It's 100% proprietary protocol. It's written in .NET and .NET Core, so it's very convenient in terms of the TCP sockets are also .NET and .NET Core based. It's 100% peer-to-peer architecture, so there's no single point of failure. You can add or remove servers at runtime. You don't have to stop the cache or the client applications which are connected to it. So dynamically, you can make changes to our running cache cluster, and NCache will not give you any issues for that. As you add a server, clients are notified at runtime, so they automatically know that this server is no more, is part of the cache cluster now. So they start using the additional server. Cluster automatically adjusts. Similarly, once you remove a server, other servers detect that this server is gone for good. They notify clients, and clients stop using the lost server. There's a connection failover support, which is also built on the client end. So any server going down will ensure that the cluster will ensure that the clients are aware of it and they fail over the connection and start using the surviving servers. So in any case, any changes in the cluster are propagated to the clients. Clients are intelligent. They are always aware of the state of the cache cluster. So this ensures that there is no downtime or data loss, because we have replication support built into it as well. So NCache is highly available, and also it's very reliable with the help of replication. It ensures 100% uptime on the application end. Without any application interruption, you can continue using NCache. Next, I'll talk about the caching topologies. That's the main portion I wanted to cover. We have 4 options to choose from. First option is again for smaller configurations. These dictate how you would configure a cache. So we have an option of configuring a cache using a mirrored cache topology. And the way it works is that you only have 2 servers at max. One of those servers would act as a active server where all the clients are going to be connected. The other server would act as a passive server which sits as a backup. And backup is done by NCache. This topology, once you configure it, it automatically follows the architecture. You don't have to basically define that this becomes active or this becomes passive. It's done by NCache automatically. But once you do that, what will really happen is all the client applications would connect to active server, and that's where they're going to read and write data from. Whatever data that we have on the active server is going to be backed up on the passive server through an async mirroring option. So client updates the active, returns. So cost of replication is not incurred on the client application end. Client application will be super fast. Behind the scenes, NCache would update the backup. And the backup is all there for an important reason. If a server 1 ever goes down, the backup server automatically gets updated as an active server. And clients fail over the connection and start using the newly active previously backup server. And now the first server comes back in, it will again join as a backup node, not as an active node, because we already have an active in the cache cluster. And all of this is done seamlessly to your applications. You don't have to make any interventions when a server is added or server is lost. This topology is very good for reads as well as for writes. So good for reference, good for transactional data, but it has a capacity issue because you only have 2 servers at max, and out of those 2 servers, only 1 server is active at any given point in time. So for smaller configurations with reliable data, caching, this could be one of the options. Moving on, second option is replicated cache. This is again for smaller configurations. This works in such a way that all the servers are active. As you can see, server 1 and server 2 both are active. Clients are divided among different servers. So if you have 6 clients, as shown in the diagram, some of them would connect to server 1 and some would connect to server 2, right? These 3 are connected to server 1 and these are connected to server 2. This is done automatically. The connection balancing is something which is built inside NCache. All servers are active, but each server has a copy of cache. So whatever data that you have on server 1, a copy is on server 2. And this copy is maintained with the help of sync updates. So whatever updates that you perform on one server, those updates have to be applied on other server in a sync call. And by that, what we mean is client is going to wait until that whole operation is completed. If operation fails on any server, the whole operation is rolled back. And that's how we achieve a 100% synchronized copy on all servers. Now, this is very good in terms of reliability, but and also if you have a read intensive use case, because you have more copies of data or more copies from different servers. So as you have more servers, your reading capacity will increase because you have more servers to serve requests. But as you've just noticed that we have a sync update, so any write operation has to be applied on all servers. So it's good for smaller configurations for write capacity. If you have 3 or 4 servers, you have to apply same operation 3 or 4 times. So that can negatively impact write's performance. So this topology is more recommended for reference data scenarios, for smaller configurations. It's scalable for reads, not very scalable for writes, but it's very reliable. It brings in high availability and data reliability because if you lose any server, for example, server 1 is lost, there's no data loss or downtime because these applications will fail over and start using the surviving server and they have a copy of cache already available. Next option is that you can choose, you can configure a cache using partitioned cache. Now partitioned and partitioned-replica are our most popular topologies. Partition cache allows you to distribute data among your available server nodes. For example, if you have 2 servers and you have some data, half of the data would go on server 1, half of the data would go on server 2. Data distribution is also part of NCache. It's not something that your applications do. It is done automatically by applications at runtime. There's an intelligent distribution map and hash algorithm and that dictates which data is going to go to which server. So based on that, your applications are the ones which are going to distribute data evenly among all servers in the cache cluster. Now data is evenly distributed, so your request load will also be evenly distributed. So this will give you more reads and writes capacity based on number of servers. If you have 2 servers, you have 2 servers working in a team. And if you grow from 2 to 3, you have more servers handling your read and write requests. So you get more scalability for reads and writes. So in a linearly scalable manner, you get more scalability if you add more servers. By adding more servers, you're also pooling the memory resources as well, because data is distributed. So you're pooling the storage of all servers together. So if you have 2 servers, you have a capacity of 2 servers. If you add a 3rd or 4th server, you increase your capacity by those many servers. So overall capacity is pooled. So you get a linear growth as you add more servers in the cache cluster. Very good for reads, very good for writes, very scalable for reference as well as for transactional data. Only downside of this topology is that it doesn't have any backup. If you lose a server, you lose that partition. So when that happens, you have to have a way to construct that data from a backend database. So if your main goal is to achieve high performance, if a performance centric application and you can afford to go back to a database, which commonly is the case, you're not relying on NCache for high availability and data reliability, this is going to give you the best performance in comparison to all other topologies. But if you need high availability and data reliability requirements to also be served from NCache, I have a better topology, which is called Partition-Replica cache. Now overall architecture is exactly like partition with an enhancement of replicas, where each server has partition of data, but every server maintains 2 partitions: an active data partition where clients are connected, and a backup partition of another server. Server 1's active, its backup is on 2. Server 2's active, its backup is on 1. And you have ability to choose sync or async backup options. If you choose partition of replica with async, client will update the active partition and will return. That operation is completed on the client. And then NCache will update the backup partition behind the scenes. If you choose sync, client application will update the active and backup as a transactional operation. Either way, sync is obviously more reliable, async is faster. But in either way, NCache is able to handle the data reliability in such a way that if any server goes down, the backup topology becomes activated and you don't see any data loss or application downtime. Right? So let me quickly show you this topology with 3 servers. So we get all the benefits of high performance for reads, high performance for writes, linear scalability for reads as well as for writes. In addition to that, we get scalability, high availability and data reliability benefits. If any server goes down, there's going to be no data loss or application downtime. I hope it's clear. Let me take you to our demo environment now, and let me quickly show you how you can construct these caching topologies, and then I'll also show you how to quickly test a cache cluster. But in the meantime, please let me know if there are any questions.
Well, just a quick reminder that everything that we're showing, we can also do with you with hand-holding sessions and technical support sessions in your environments for your specific use cases. So everything that we discuss here, even post-webinar, we'd be happy as a team to be able to get together with you on that as well, to be able to demonstrate how it would work for you. As far as questions go, I do have one that came in just right at the end. One of them is one of your favorites. There's been a lot of discussion regarding the use of Hazelcast for application caching. What does NCache provide that Hazelcast does not?
Okay. First of all, it's a more of a debate. NCache is actually written in .NET and .NET Core. So preferred platform NCache is Windows. The nice thing about NCache is that it runs on .NET as well as on Windows as well as on Linux. So platform and compatibility support that NCache offers, there is no other product that is able to achieve that. So that's the first bit, where it is more preferred choice if you're considerate about the platform that you're planning to use. The other difference is, and I would encourage everybody to go look up on our comparison pages. You would find very good material over there as well. But to quickly summarize this, NCache object caching support has a lot of features which other products completely lack. For example, the SQL searching, we have an elaborate set of features available inside NCache. We have cache loader, cache refresher. Those are features which are completely unique to NCache. Our read-through and write-through handler with an ability to run .NET and .NET Core code on the server side. That's something which is an absolutely unique feature to NCache, and list goes on, right? So some of the features that you can customize on the server side, those are only available on NCache. And then from an application standpoint, there are a lot of features which are missing in other products. So I would encourage everybody to check our comparisons page. There are some comparisons, feature by feature comparison published, and that will give you more detailed information on that.
This is definitely our favorite line of questioning, whether it's a webinar or even a tech solution. It could be Hazelcast, it could be ScaleOut, it could be Redis, but
Yeah, that's right.
Thank you very much, Ron. I think we're good to go. Please continue.
Sure. So let me give a quick demo of the product by creating a new clustered cache. Let's name it test cache. Right, let me move this bit here. Just bear with me. Okay, so, and we just explained 4 caching topologies. I'm going to go with partition of replica cache because that's the most recommended one with async replication option. I'll keep all of these default. Move on. And I'll show you how easy it is to configure a cache using GUI tools. This is our web manager, but you can achieve everything using our PowerShell commandlets as well. And you can automate this deployment as well if that's a requirement. I'll add server 1 where NCache is installed. I'll then add server 2. So my 2 boxes with NCache with size of 2 gigs is going to be set up. So my idea here is that I'm going to create a 2-node cache cluster using 2 gigs of cache size on each. So total of 4 gigs with 2 servers where NCache is already installed. And then I'll use my box to connect to this cache cluster. TCP parameters. This is the port that you need to set up. Once you do that, keep it default or specify any port where firewall is not impacting that port. If you need to set up encryption and compression, this is the screen. I'll just keep it as is. Choose next. Evictions. If your cache becomes full, it's something that you can choose. One option is that your cache is going to simply not entertain any write operations. It will give you an error, cache is full. Other option is that you set up eviction, and based on these algorithms, it will remove some of the items from the cache at runtime. So based on priority, usage, least recently or frequently used items can be removed, and 5% of the items are going to be removed from the cache. I'll start this cache on finish and auto start so that every time my server reboots or NCache server restart, it is able to restart the caches which are stopped. I'll choose finish, and that's it. That's how easy it is to set up a cache cluster. And in a bit, it will show me another view where this cache will be started, and then I'll show you some monitoring and management details from there. We have some more detailed videos available on cache configurations. So if there are any questions, let me know now, or we can rely on those videos as well. I can select and choose monitor cluster, and that will open another dashboard which will allow me to fully monitor my cache. It shows me a fully connected cache cluster, request, throughput counters, latency counters, and then additions, fetches, update counters are also there. Similarly, it shows me CPU and memory usage and cache full situations. I also have dashboards for client as well as a report view where we see server side and client side dashboards. At the moment, there is no application which is connected to it, but there is a way I can simulate some load using this test stress button. So I can start a dummy load or some activity on my cache cluster by calling this test stress. As soon as I will do that, you will see one client is connected, and this topology requires that my data is going to be distributed, right? So some data would go on server 1 and some on 2. So this client is evenly using both servers. As you can see, requests are coming to both servers. Cache size is growing on both servers. we have active and backup partitions also showing on both servers. And if I quickly show you the latency counters, it's sub-millisecond latencies, even microsecond latency as far as my operations are concerned. And I can see the client dashboard showing these client-side statistics, and similarly we have a report view which is showing the server-side statistics. So
Ron, I got a question. Actually, we got a couple questions that came in. So one of them is, what is your recommendation for eviction? And if eviction, at least, hold on, the next one is, if eviction is turned off, can we increase the cache size or decrease it?
Sure. So, eviction is something that needs to be set up based on your use case, right? If data is something that you can afford to be evicted, right? Eviction itself is going to remove some data if your cache becomes full. The ideal situation is that you never have to do that, and your cache is well within the capacity, right? So you give enough size or enough memory to your cache so it never becomes full. But if even in cases where it does come to a point where it becomes full, in that case, if your data is something that you can always reconstruct from a backend database, evictions are recommended to be turned on. For example, for ASP.NET sessions, we don't recommend turning evictions on because you would be removing some users to make room for the new users, and all users have their data of importance, right? So it's a data that you wouldn't want to lose in any given scenario. So for those scenarios, we recommend that you increase your cache size. You plan your caching size in such a way that it is big enough, and in cases where it becomes full, NCache allows you to change the cache size at runtime. You can edit this, right? And based on that, you can increase and then save these settings on a running cache. So it is hot applicable, and it will increase cache size at runtime. Any other questions?
Looks like that answered it, and I'll save a couple of them for the end so that you can complete your demonstration.
Sure. So coming back to my demo environment, you can add clients. For example, I can add my box as a client, and this is a quick overview of a sample application which I can run from my box. For example, this is available from GitHub as well. So if you search NCache on GitHub, you would see some samples, and I've extracted one of the samples from there. So what you really need to do inside your application is include this NuGet package, which is alachisoft.ncache.sdk. And if you're interested in app data caching, this is the sample that you should consider. And based on that, once this is added, you can include some resources inside the application. This will already include some libraries of NCache as part of this NuGet package. And then you include this reference using alachisoft.ncache.client. Also add runtime.caching, right? And based on that, you can define a cache handle. And within this, we have a bunch of methods. For example, let me show you how to initialize cache. Let's actually go inside this. Please bear with me. I'm having a hard time. Anyways, for some reason I'm not able to actually go inside this. I think there's an issue with the box itself. But anyways, the APIs are pretty intuitive. Let me show you from our PowerPoint. This sample is actually using that. I'm not able to demonstrate because I'm not able to step into the code. It's just not letting me. So this is cache handle, and this is the piece of code that I wanted to show, that the cache manager.getCache will allow you to connect to the cache. Then you can call cache.get to actually get any data from the cache. Similarly, you can call cache.add or add async to add or update, to add any records in the cache. And similarly, insert is an upsert, where it adds as well as updates data in the cache. And similarly, you can call cache.remove. So this sample is available that you can download and run against your cache, all you have to do is point to the cache from an application end. There are a bunch of configurations. You can specify the name of the cache and IP inline, or you can rely on a client.ncconf, which this NuGet package includes in the project. So if I quickly show you some resources, you see a lot of files are actually added, and this file right here is a file which allows you to connect to the cache. So it's already able to connect to my demo cache. If I run it, it will do some activity against my cache and will start the caching operations. Similarly, I have another sample which is going to give you some more options. For example, there was a question about searching inside NCache, right? So I would recommend that you use this sample right here. This is for SQL searching. It's again downloaded from GitHub, and again it's using search using, it has a sample data, and then it's calling search using SQL, and it has a bunch of features right here. Again, on the same lines, the samples are pretty intuitive. You can insert items, and then you can query using name tags. You can query, encourage using defined indexes or projections. Unfortunately, I cannot go inside these methods because of the environmental issues. But again, these would serve as a great reference points for using NCache from any application that needs to use caching for within the application, or for they have a use case of searching within the application. Towards the end, I will go ahead and show some. There was another question about client cache. So this topology is also a no code change option. Any data that you cache from a database inside NCache, you can further cache it by using client cache. It's a cache on top of another cache, works without any code changes. It's a synced cache with a clustered cache, so there's no data consistency issues. Synchronization is done by NCache. Any updates made on one client cache are propagated to the clustered cache as a must, and then propagated to other client caches, and NCache manages all the synchronization. For reference data scenarios where you do not have a lot of writes, this is a very recommended option to choose from. And similarly, NCache also has a WAN replication. We have active passive and active active topologies. So your entire cache data can be replicated from one data center to the other through our bridge cache. Bridge itself is backed up on active passive server. So you have a source cache and you have a target cache. One-way replication or east to west migration of data from one data center to the other. For DR scenarios or for east to west migration, or for situations where you need data from one application and you need to use it to the target application. So you can transfer entire cache data from one data center to the other. The other option is active-active. In this, we have both sides active. So side 1 is transferring data to side 2, and side 2 is transferring data to side 1. Again, it's a no code change option. It's just a configuration. Once you set up bridge, you connect two caches together, and NCache takes over, and it starts replication of data between those caches. And this is also extended to multi-active topology as well. So it doesn't need to have just two sites. It could be 3, 4, or 5 sites where all sites are transferring data to one another. So NCache has the ability to actually sync data from all sites at once. And by the way, this is done asynchronously. So cost of replication is not incurred on the application end or on the user end. It's done on the application. You have client applications connected here as well as here. They do not see any performance degradation because of this WAN replication. It's done behind the scenes by NCache. Let me know if there are any questions. Let's conclude the presentation and feature set at this point. Zach, let me know if there are any questions.
Yeah, we do have a couple. And everyone, I do appreciate your patience. So this is also a good time to toss in any other questions if you have been wondering throughout the presentation. So let's start with one. How do you confirm if your cache is running in a healthy state? Do we get any kind of notifications, etc.? Like, how do we know if there's an issue?
Sure. We have monitoring and management tools. So one thing could be that you visually inspect and you see the cluster health. You see the CPU usage, RAM usage, If you know your baseline, how much requests your applications are generating, and what is the typical utilization of NCache based on these counters, you can visually inspect using our monitoring and management dashboards. And then we have alerts for any situations. For example, you start a cache, stop a cache, a node joins, leaves, cache size becomes full, or a cluster goes in an unhealthy state such as split brain. We have alerts which we log into Windows event logs. And then you can also set up email alerts from NCache, and it can generate an email to you as well. So this is something that will be proactive monitoring, some alerting from NCache, where NCache would alert, and you can take actions based on that. And then we have historical data captured in the form of perf1 counter logs as well as cache logs. For those situations where you didn't know what went wrong and you saw some issues with NCache, we can come and get involved, and we can review NCache logs and make an assessment of the cache health in that case. So there are a lot of avenues in this regard which we can explore.
Sounds good. Another question is, what is the latest .NET version that NCache currently supports for the clients?
Okay, typically NCache, we tend to be on the latest .NET framework version, .NET Core. So .NET 6 is currently supported. That is a prereq for NCache. You need to have .NET 6 as a mandatory thing on NCache servers, but your applications can be on any .NET framework. I think from 3.5 onwards, 4.0, 4.5, or even 4.7, 4.8. Your applications can be on either any of the .NET or .NET Core framework. It's only a limitation on the server side. And as soon as a newer framework compatibility is tested, for example for .NET 7, we are already testing it in our QA lab. So once we have that signed off, we will release an official support for that as well.
Wonderful. Another question is, what would you consider is the safe amount of clustered caches between my cache servers? Can I make, say, 15 clustered caches between my cache servers?
Okay. First of all, NCache does not enforce any limit on how many caches you can configure. As a matter of fact, if you look at my demo environment, I have 2 caches configured. So you can create as many as you need to. But there is a technical recommendation or a capacity related recommendation that we typically recommend in a production environment to not go beyond 4 to 5 caches, because every cache is a separate cache cluster. It is going to bring in it is actually going to consume all the resources for storage, for clustering, for communication. There's a cluster management overhead as well. So as you grow number of caches, you're actually introducing that capacity issue on that environment, or within that environment. So we recommend keeping it, within 4 to 5 if possible. In a situation where you have to have multiple caches, you can extend it up to 10. But like I said, it's again a recommendation. There's no actual limit which enforces this. It's a general purpose recommendation from our end.
Okay, let me just toss in one more, since I know we're at the end of the session and I know folks have other things on the Docker. Can NCache provide DR replication?
Yes, it does. The WAN replication feature that I just discussed, the last topology, that covers the DR. Disaster recovery, sites can be, transmitted with the data from active site. So you would have a DR site fully backed up. You just have to make switch on the application end. Since all the data is already backed up, there's no data loss in that situation where one data center completely goes down, or you need to bring it down for maintenance yourself.
All right, I think we pretty much nailed as many as we could. Ladies and gentlemen, please know that we are available outside of these sessions as well. We're very happy to work with you side by side when it comes to looking at your existing configurations. If you're already a user of NCache, if you're new to NCache, we'd be happy to get you set up with a trial and have hand-holding sessions to walk you through how this would work in your integrated applications. But most of all, please know that you can reach out anytime when it comes to any queries about NCache or even using the product, and if you need any help. We've got a lot of new stuff coming up on the way, new version releases too. So, keep in tune, and we'll have more of these webinars on the way soon. But a round of applause for Ron. I really appreciate you taking out the time for our session today, and looking forward to our next one.
Thank you, everybody. Thank you, Zach.
Of course. All right, everyone. You all have a wonderful day, and we look forward to seeing you in our next webinar. And just a disclaimer, after this webinar is over, we will have a recording of the webinar uploaded to our website once all is done and dusted. So if you didn't have a chance to, have any questions answered, if you'd like to revisit any of the points we've made, please feel free to come to our website again and check out the recorded webinar. All right, then. Salute to everyone. You have a good one.
Thank you, guys.
Bye-bye.